Hello, so I wanted to do a video today on probabilities and how they sum to 1. You might have seen questions like this in an exam where you're given a table and you have to find out some missing values, the missing probabilities in those tables. So these are the kind of questions that I'm going to go through today. Before I do, I'd just like to go through a couple of areas that you need to be really comfortable with in order to do these questions. So the first one is, especially for the examples I'm going to do today, is with adding and subtracting decimals. And secondly, you need to be able to convert between fractions, decimals and percentages. To get to the more tricky ones, I'm not going to be looking at any kind of fractions or percentages today. We're just going to be keeping it simple and starting with decimals. So firstly, you need to remember that a probability scale goes from impossible all the way up to certain. And impossible we represent with 0, and certain we represent 1. So is represented by 1 rather. So probabilities have to take any value between 0 and 1. Now they can be written as a decimal. So if that's 0 and that's 1, midway through would be 0.5. A fraction, well, this midway through would be a half, and if I was doing it all in halves, this would be 2 over 2, which is equal to 1, and this would be 0 over 2, which is equal to 0. You could also have a percentage, that's 0%, 50%, and 100%. Now each of these things here represent the same thing. So 0.5 is the same as a half, which is the same as 50%, and 1 is the same as 2 halves, or 100%. We need to bear that in mind, because what we're going to be doing now is looking at a question like this. So before we come on to those questions with tables, you could be given just a simple question like this and be told that the probability that I win a game is 0.2 and asked to find the probability that I do not win a game. Now there are two options here. If I do not win the game, I could lose it, I could draw it if those are options. However, in both of those cases I still do not win the game. So it is absolutely certain, if I play this game, that I either win or I do not win. So because it is certain, that tells me that the probabilities must add up to 1. So if I'm told the probability of winning a game is 0.2, to work out the probability that I don't win the game, I simply need to do 1.0 take away 0.2. When you do this, remember it's really important that you line up your units and your tenths and your decimal place. So here, this is what I meant at the start when I said you need to be comfortable with adding and subtracting decimals. 0 take away 2 we can't do, so we borrow 1 from the units. That becomes a 10. 10 take away 2 is 8. Put the decimal point in. 0 take away 0 take away 0 gives me 0. So the probability that I don't win the game is 0.8. Okay, now let's go to the kind of table questions. So Amy chooses an evening activity, and the probabilities of each of those activities are shown in the table below. We're being asked to find the probability that Amy chooses the cinema. So that's this bit here. Now you need to remember that all of these probabilities in the table must add up to 1. So I don't know what this one is, but I know that if I add 0.2 and I add 0.1 and I add 0.6 to it, because if she's choosing one of those activities and nothing else, those are the 4 options. That is every possible outcome, therefore they have to add up to 1. So what I would do with these is to just add these bits up first. So 0.2 plus 0.1 gives me 0.3. Add another 0.6, that gives me 0.9. So something plus 0.9 gives me 1. A lot of people would make the mistake of adding them up and then they forget to take that 0.9 away from 1. Because to find out what that something is, I'm just doing 1 take away 0.9, and that tells me that the probability that she chooses the cinema is 0.1. Okay, next example. You need to watch out for these sorts of questions. I've put this question in here because it's the same kind of question. However, the decimals here, the first one only has one digit after the decimal point, the 0.5, and all the others have 0.12 and 0.28. So it's the same idea. Sweets in a bag are either strawberry, vanilla, chocolate or lemon. We need to, what if one's picked, we need to find out the probability that it's vanilla. So when you do these questions, it's really, really important to line up your units, tenths and hundredths when you add them up. A lot of people just see that 5 after the decimal point, the 12 and the 28, so they would just do 5 plus 12 plus 20, 5 plus 12 plus 28 and put those digits after a decimal point. Remember, it doesn't quite work like that because the 0.5 represents the number of tenths, the 0.12, the 1 represents the tenths, the 2 represents the hundredths, and then the 0.28, the 2 represents the tenths, and the 8 represents the hundredths. With these questions, I suggest you fill in any blanks with a decimal point. Use a 0 as what we call a placeholder. Now, we're going to start by adding these up. 0 plus 2 plus 8 gives me 10. Remember, the 1 comes down under the tenths, and the 0 goes there. 5 plus 1 gives me 6. Plus 2 gives me 8. And then add the 1 gives me 9. So that there is these three probabilities added up. So that is not your final answer. Remember, all 4 of these options, there are no other options, so it is certain if I pick a sweet that it is one of these sweets. Because that is certain, that means the probabilities have to add up to 1. So what I'm now going to do, the second step, is to do 1 and I'm taking away from that, excuse me, 0.9. You could put the 0. It's not really important that you do that because there's no other digits after the 0. So I'm now going to do my units, my tenths, and my hundredths. 1 take away 0.9. Remember, you must fill in any missing points. 1 is the same as 1.0. I didn't actually need that one. And then I'm just going to do the taking away. So 0 take away 9 you can't do, so we're borrowing 1. 10 take away 9 gives me 1. 0 take away 0 gives me 0. So that there is the final answer. That's the probability of... Is it a... No, that was a question. The probability of picking vanilla is 0.1. Okay, last 2 examples. These wordy ones tend to catch people out. So Becky can either be early, on time or late for work. The probability that Becky is on time is equal to the probability that she is late. And we have to find those missing probabilities. Now, there are 3 options here. She can be early, on time or late. We are only given one of the 3. However, we are told that the probability of her being on time and late are equal. That means they are the same. So if I just draw a box to represent this probability, because being late is the same, these 2 boxes that I've just drawn are going to represent exactly the same number, exactly the same decimal. So I know that 2 lots of this box add 0.6 is equal to 1 because there are no other options. It is certain that she is either early, on time or late. Okay, so to find out what 2 lots of this box are, I need to take away 0.26 from 1. So if I take away 0.26 from 1, that 2 lots of this box gives me 0.74. That's 2 boxes. I want to find what 1 box is so I can fill in each of these. Because they are equal, that means if I were to split it exactly in half, that would tell me what one of the boxes are. Now, splitting something in half in maths, another way of saying that is that we are dividing by 2. So I'm going to use my bus stop method. I'm going to write 0.74. and I'm going to divide it by 2. Now the bus stop method works the same with dividing decimals as it does without. You just need to remember to put your decimal point in and line it up above the bus stop as well. So if I've got 0, how many 2's can I make out of that? That answer is 0. If I've got 7, how many 2's can I make out of that? Well, that would be 3 wholes, but don't forget what's left over. 3 lots of 2 is 6, so I would have 1. And then how many 2's go into 14? That is 7. So that tells me that each box is worth 0.37. So now that I know what one box is worth, I can rub that bit out, and I can write 0.37 and 0.37. It's always worth just checking with your final answer that these 3 add up to 1, which in this case they do. And just double check in the question as well, the probability that Becky is on time is equal, the same as the probability that she's late. So our answers kind of make sense there. Okay, last example. These tend to catch people out. Again, there are 2 things missing. The options for the sweets are strawberry, vanilla, chocolate and lemon. But there are 2 things missing. And we need to find out what those are. So, reading the question, the probability of picking strawberry is double the probability of picking lemon. Now, what a lot of people do is they just see this double. They find out they add these 2 together and then find out what would make that up to 1, and then they just split it in half. Trouble is, that's what we did with the last example, and if I split it in half, that means strawberry and lemon would have the same probability. So if you think of it this way, the probability of picking strawberry is double the probability of lemon. That means whatever goes in here has to be 2 times what goes in here. So actually, I'm going to use the boxes again, and I'm just going to put 1 box in lemon, and because the probability of picking strawberry is double the probability of picking lemon, I'm just going to put 2 boxes in there. So we'll come back to those in a second. I'm going to add these up to start with. So 0.21 plus 0.52. If I add those up, 1 plus 2 is 3, 2 plus 5 is 7, and 0 plus 0 gives me 0. So I know in this case now there are 3 boxes, not 2. So 3 times 1 box add 0.73 is going to give me 1 whole. Now I'm going to take away 0.73 from 1. That will tell me what 3 boxes is worth. So in this case, that's 0.27. So if 3 boxes are worth 0.27, I now want to find out what 1 box is worth, because then I can use that to fill in my values. So I'm just going to write out 0.27. We're dividing that by 3. 3's into 0 don't go. 3's into 2 also don't go. So I'm going to cross that 2 out because I haven't used it yet and carry it over. How many 3's go into 27? That would be 9. So that tells me that each box is worth 0.09. So the probability of getting lemon is 0.09. Remember, strawberry was double that, and we've drawn 2 boxes to represent that. So if 1 box is 0.09 and we've got 2 boxes, I'm just going to do 0.09, add another 0.09, and when I add these together, that's going to tell me that this probability here, the probability of strawberry, is 0.18. Okay, that's all the examples. You do need to be aware that these questions might also involve fractions and percentages, but I've just stuck to decimals for the time being. So I've made another one of my question generators, and you can, when you open the file, you must click Enable Content. That'll appear in a little yellow ribbon at the top. Otherwise, if you don't do that, the buttons won't work. So you can have a go at these questions as increasing difficulty. So each of these 4 examples are just like the 4 examples that I've just done. If you want to try a particular type of question, just practice those, you can do that. Or when you've got the hang of all of them and you want a bit of practice, I don't tell you what kind of difficulty the question is. You can just practice getting a mixture of them, and then you can get your answers at the end as well. That's it. I'll upload that link to that file in the description as well. Thanks very much for watching. Bye bye.